Guys, we're back with day 40 here. I talked about this a little bit in class today, but I want to make sure I get it into the notes so to make sure everyone has it. Then I want to talk about different ways that we can use this local linearity. So the first thing is, how do we determine over or under estimates with local linearity? We can't always determine it, but sometimes if we're given the right piece of information, we can determine it. So let me give you an example problem. Okay, so look at this setup here. Here's what we know. We know f of 4 equals 2, f prime of 4 equals -3, and f double prime of x is less than 0. It says find the equation of the tangent line at x equals 4 and estimate f of 4.1. So that's just like yesterday. But the added on part, okay, that was new today and we talked about a little bit in class, is your estimate an over or under estimate? Okay, but to solve this thing, let's start from the beginning. Okay, the first thing I need to do is find the equation line at x equals 4. Sorry, I should say equation of the tangent line 2f at x equals 4. Again, to write an equation of a tangent line, we need a point and a slope. Our point here is the point 42. Right, we see that here, x, y, and then f prime of 4, that would be the slope of our tangent line, would be -3. Okay, to write an equation of a line, I'm just going to simply do y minus 2 equals my slope times x minus 4. So there's my equation of the tangent line to f at x equals 4. Now I want to estimate f of 4.1. Now again, I don't know f, so I can't plug 4.1 into f. Well, what I can do is plug 4.1 into my tangent line, and what's going to happen is I'm going to get an answer that's pretty close to the right answer. So I'm going to plug 4.1 into my tangent line here. And I'm going to do 4.1 minus 4 is 0.1. Then I'm going to do -3 times 0.1. -3 times 1 would be -3. But I got to move that decimal once, so this is going to be -0.3. And then I'm going to solve for y and get y equals -0.3 plus 2 is the same as 2 minus 0.3, which would be 1.7. So now I know f of 4.1 is approximately 1.7. That's my answer to the second part of the question. The third part of the question here says, is this answer, this estimation of 1.7, an overestimate or an underestimate? Okay. Well, for that we need this piece of information right here. Concavity will always tell us whether a tangent line approximation is too big or too small. So right there we see f double prime of x is less than 0. What you need to know, right, this is from definitions from previous units or previous standards. This means f is concave down. That's what that literally means. So what I always do is I make a little sketch of what f would look like. F then would be frowning if f is concave down. Okay. A tangent line to f, I'll use green for my tangent line. A tangent line to f right, just like the line that I wrote the equation for. Okay, that tangent line to f is always above the curve. So that answer 1.7, right? Plugging in 4.1 and getting 1.7, that came from plugging into the tangent line. So that's giving me a solution of 1.7, but I'm using it to estimate this blue point right here. And we can tell, because the graph is concave down, we can tell that our estimate point, right, is for sure bigger than the actual f of 4.1, which we're trying to estimate. Right, 1.7 is pretty close, but it's too big of an answer. The actual answer maybe is like 1.65 or 1.68. Right, we don't know exactly what it is, but we know 1.7 is an overestimate. So when we write this and justify it, here's what we say. Now, they never told me f was concave down. I made that connection based on this statement. So in my justification, I need to write that I made that connection. So I'm going to say since f double prime of x is less than 0, f is concave down. I need to tell the grader of this that I know that. Okay. Since the graph is concave down, I know that 1.7 is an overestimate. Because the tangent line will always lie above the curve. So again, if we have a concave down graph, our tangent line is always going to lie above the curve, which means our estimates are always going to be overestimates. Obviously, if f was concave up, then the reverse would be true, right? If f was concave up, then here's f, then our tangent line is always going to be below the curve, which means our estimates are always going to be underestimates. Okay. So whenever I saw this question, or whenever I see this question, I always just figure out the concavity and then just sketch it to remind myself, oh, is the tangent line going to be above or below the curve? Right? A little sketch helps me remember that. Okay. Next question. Okay, so this time we're actually going to know what f of x is. We're going to let f of x equal the square root of x. So the first thing I want you to do is I want you to write an equation of the tangent line to f at x equals 4. I want to use that to estimate the square root of 3.9. Okay. Now, with a calculator, you could type in the square root of 3.9 and figure out what that is. Okay? But how could you get an estimate for it using a tangent line approximation? And I want to do this just to see how close we get. Okay? So the first thing we want to do here is write a tangent line to f at x equals 4. So again, to write a tangent line, I need a point and a slope. So here's how I'm going to do that. My point now is not quite as obvious. The x part is 4. To find the y part of the point, I'm going to have to plug it in here. The square root of 4 is 2. So f of 4 is 2. That's the second part. To calculate my slope, then, I'm going to have to plug it into the derivative, right? So if f of x equals the square root of x, I need to do the derivative and then plug in 4. Well, in order to do this, I'm going to rewrite square root of x as x to the 1/2. And I'm going to get f prime of x equals 1/2 x to the negative 1/2. Okay? Rewriting this to be a little bit easier to evaluate, I'm going to throw that negative exponent down into the denominator and call it 1 over 2x to the positive half, which is 1 over 2 root x. Therefore, f prime of 4 would be 1 over 2 times root 4. Root 4 is 2, 2 times 2 is 4, and I'll get 1/4. So my tangent line equation would look like this. Y minus 2 equals 1/4 x minus 4. Go ahead and solving this thing out here. Right, this is my tangent line equation. Now I'm estimating the square root of 3.9. So that's like when I'm plugging in for x. Now what I know is 3.9 minus 4, that should be a negative number. It's going to be negative 0.1. Okay, and since I'm going to end up looking for a decimal here, I'm going to change everything to decimals and call it y minus 2 equals 0.25 times negative 0.1. So 0.25 times negative 0.1, right? I'm just going to think of this as 25 times negative 1. That'll give me negative 25. But I need to move the decimal 1, 2, 3 places. So 1, 1, 2, 3 places. So it's negative 0.025. And then I want to add 2 to that. So negative 0.025 plus 2 would be the same as 2 minus 0.025. So I can't do 0 minus 5, so this is going to be a 9, this is going to be a 9, this is going to be a 1, this is going to be a 10. 10 minus 5 is 5. 9 minus 2 is 7. 9 minus 0 is 9. So I'm going to get 1.975. So that's what that means. So that means the square root of 3.9 is approximately 1.975. Again, we can check on our calculator here to see how accurate that is, right? Just give it a second to load here, and we'll check the value of the square root of 3.9 and see how close it is to 1.975. And you can see, right, the number's irrational here, but it's pretty darn close to 1.975, right? So we can actually use it to estimate things that would be difficult to estimate without a calculator, but doable without a calculator. So that's it for today. I'll see you guys tomorrow, last day before Christmas break. Talk to you guys later. 2 trains. Bye.